Now we are going into 7.5 and we look at the properties of logarithms, okay? The properties of logarithms are like the grammar in your English. If you know your grammar, you can put together the sentences in correct grammar and, correct meanings. So these are the properties, and you guys are no strangers of exponential properties. And now this is the properties of logarithms. You have the product, okay? Look at this. Let A be n, these are positive numbers, and the case that B cannot be 1, okay? So the product of logarithms, log of base B of m times n is log of bm plus log of bn, okay? It's in your page 507. And the quotient, log of base B, m divided by n, then this is the property, okay? Log of bm minus log of bn. And then the power, log of b, base b, of m to the n exponent, or m to the n power. Then you bring n down, then you got that right there. Okay, let's do example so you can see right away. Here we go. Example A, you see right now, okay, you have log base 4 of a quotient 3 over 7. There we go. Okay, if you have this right here, if you want to really evaluate that, you can punch into the calculator, but just to do an expansion or to simplify them and see them in the simplest form, which rule are you going to apply? The quotient 3 over 7. You see, 3 over 7, then this can be rewritten as, that's right, log base 4 of 3 minus log base 4 of 7. There we go. Okay, and then you just plug the value in. Use your calculator, log base 4, okay, of 3, and you will have, let's say, 0.792, and minus log of base 4, 7, you got 1.4, and then you have a negative value, okay? What about B? What about B? Part B, you have log of 421. There we go. Log of 421. What do you do with that? Well, just in case you want to just right now, you see I do this. Why do I do this? Because they gave you, in example 1, they gave you the value, okay? Sometimes in your calculator, you have to adjust your base. But in some specific problems, they already provide you log of base of 3, okay, is 0.792. And then they provide you another value, log of base of 4 of 7, and that is 1.4. Okay, so by giving these two options for you, by giving these two values right here for you, then you can just go ahead. You can just go ahead and convert the m and n into these values, 3 and 7, so you can have the values right away. And now look, example B right here. Well, it's going to be, if you don't have your calculator, this is all they give you. And you think, right, this, Mr. Dang, I can rewrite log of 27 into what? Log of base 4. 27 is 3 times 7. No, sorry, 21. 21 is 3 times 7. There we go. You see that? So that is the idea of really using the given data right here, which is log of 4.3 and log of base 4.7. Then how do I evaluate log of base 4 to 21? I'm just simply rewrite 27 as 3 times 7. And now using the product property. And that is, look at this, product property will be 4 of 3 plus log of 4 of 7. Now you have everything. What is log of 4 to 3? That's right there, 0.792 plus, what is log of 4.7? That is 1.4. Give you another decimal, that would be 0.4. 0.4. So you get the idea right there, okay? If they provided you the specific value for certain base and certain, log of whatever that is, then be mindful of converting that. Either it's a quotient, it's a product, or it could be a power. Okay, so look at this. Let's go for the power, part C. Okay, example 1, part C. All they give you is log of base 4 and 49. Well, let's say you are not allowed to use computer. Well, use calculator. Then you can rewrite this one for me. Well, 47, think of what times what give you 49 in terms of 7 or even 3. In this case, 7 would work best. Rewrite this guy for me, and that is 4. And then 49 is technically that's 7 square. Does that make sense right here? Okay, so you see, now you see the idea right now, by doing that, I now can apply the property right here. See, log of base 4 of 7 squared, I simply bring 2 out, just like n. 2 right here is n. So you see that, bring 2 out, and what I have right now is log base 4 of 7. And now I can rewrite 2 times log 47. What is log 47? That is 1.404, and you got your victory, which is 2.808. There we go. All right, that makes sense for you right there. Let's move into another variable form of logarithms, and keep this in mind, guys. Swallow this, okay? This is your friends. These are your buddies, your tools to really fight the battle well in logarithms. All right, so here we go. Look with me in example 2. You will see now you have as log of 6, base 6 of 5x squared over y. For some reason, they just want you to expand this expression right here. Then you just do simply log, look, quotient, so base 6, what? 5x squared, okay, over y, which is minus log of base 6 of y. Okay, are we done here? No, we have another product, 5 times x squared. So this one right here, I'm going to expand this one too. And that is log of 6 product 5 plus log of 6x squared. And now bring that down, which is log of base 6y. Okay, are we done yet? No. What about this guy? Power, the power property. So now I just simply, you can punch a calculator, but just want to just simplify. Look, bring 2 down, So you got bring 2 right here, okay? That's the formula of power property of logarithm. 2 log of 6x. Now, ladies and gentlemen, this is the expansion of that guy right here. You see it? And sometimes they want you to do reverse, giving you this, and they ask you to simplify into that form, okay? There we go. So now let's do ACT and SAT problem. In your example, they gave us a very good, expression of the logarithm. Suppose you have right now is log, this is example 3, log 9. Now, can you tell me if they don't give you the base, but they just give you log of 9, what's the base here? That is correct, 10, okay? So that is understand in a common language of mathematics. If they don't provide they don't provide 10 or the base, then it is understand the base is 10. Log base 10, 3. Okay, they ask you to do what? Which of the following is equivalent to, they gave you A, B, C, D. Well, let's go for a ride. So here you go. This, one step at a time. This right here, let's do with the individual first. This, I can bring 3 into that. So that can be log, look, bring 3 in. So this is turned into exponent of 2. Got it? And now, one step at a time. This is 9 minus log of 3. Remember, ladies and gentlemen, remember your base 10. So all of these have the same base. So look, one step at a time, do the product with me right here, what you get? Product, okay? That would be log, my handwriting getting really silly. 9 times 2 to the third, which is what? 8, okay? Minus this, one step at a time. So this is a quotient rule. So you got right now as log of 9 times 8, and the whole thing divided by this guy, which is 3. So you can do, boom, right there. What you get? 9 over 3, you got 3. And 3 times 8, you got log of 24. And you can pick your answer now. Pick your answer. And that is, that's right, it is 24, and that's D. All right, let's go into one more example, and that is, wow, this lesson really fast, and I think you guys will enjoy logarithms a lot once you know the rule and you understand the history and you see the proof as well. Later on in this lesson, we're gonna prove something that you will see that is very wonderful. Here we go. Let's do just a little exercise here. How do you expand log of, let me see, log of, how about we do the expand, let's do the condense. Do the condense, how about that? Yeah, pick a problem right here in your textbook. Condense ln 4, remember ln? When you see ln, that is natural log, which is the base is e, plus 3 ln 3 minus ln 12. Okay, they want you to condense this guy. Well, let's go. What did you see over there? But before you make the move, same thing, bring 3 in. So this now will get 4. This is ln plus, look, bring 3 in, you will have what? 3 to the third, okay? My handwriting again, Mr. Dan, minus ln 12. All right, now one step at a time, These two now turn into what? That's right, it's a product. Okay, so ln of 4 times 3 to the third. Make sense? And minus ln 12. Now, product. So you got now ln of 4 times 3 to the third, which is what? Just to be sure. 3 to the third, I see something, that's 27. Got it? All right, over 12. There we go, because that's the quotient rule. Now you can see that. That is 1, this is 3. And 27 divided by 3, you got ln of 9. That's it. This is the condensed version of that guy right there. Make sense? Let's look at the key concept right now, and we are going back to the definition, and then also a very significant key concept. And I want you to look at the box at the bottom of page 508. Change of a base formula. Again, given A, B, and C are positive number, okay? Giving positive number for A, B, and C. And of course, B and C, okay? Of course, B and C cannot be 1, okay? You know the concept. Now, how do you extend, how do you develop or rewrite the log base C of A? Look, this is a very handy property. Log of C to the A. This is equivalent to log of another base B of A. See A on the top over log of B, C as the base right now turn into, that's right there. Okay, so this is the property, a very powerful property. For example, how do I rewrite a log of, let's say, 7 to the 5? Look, I can rewrite this as log of 5 over log of 7. But look, you ask Mr. Dan, they have the base 7 over here, so what would be the base over here? Look, the base over here can be any number other than 1, must be positive. But you can pick any base over here. You can pick, let's say, 3. And if that's 3, then this is 3. Got it? That works, okay? That works. B must be the same. Or you say, how about 4? Yep, 4 works too. If that's 4 up here, it has to be 4 right here. How about 15? That's work too. 15 right here, got to be 15 right here. And that's why you see B right there, same base. You can separate that A and C. There we go. Am I making sense right here, guys? And that is a very, very powerful property for you. So the next one right now, you see in your textbook right here, the next thing you see is, in particular, look, let me rewrite this for you, okay? All right, here we go. Okay, now we have, in particular, log of base CA. And now that can be, look, in this case, they just want you to know, if they just write symbol like that, means the base is 10. Got it? And it's equivalent to, Mr. Jen, can I have my base E? Yep, you can do that. If base E, it turns into ln A over ln C. That's it, guys. Swallow this. Like more tools you are receiving and put into your toolbox so that you can really function very well on these properties. Okay, we're almost there. Let's look at example 4. Okay, example 4. Now, example 4, you have evaluate log of 3/8. Okay, using the common logarithms and natural logarithms. Okay, all right. Well, if I rewrite this guy right here, I can do two things. Look, common and then use natural logarithms in a common log. What do you think when they use the word common log, which is base 10? If base 10, I don't need to write the base. Okay, there we go. And then punch in your calculator. It's up for you right there. Log base 10 of 8 is 0.9031. And log of 3, we got 0.4771. And that equivalent to 1.893. This right here, using a natural log, which is the base is 3. So the base is E. ln 8 over ln 3. And then you punch in your calculator, that's 2.0794. This is 10986. And look, you will have 0.893. This is to prove the point that the same base, you pick any base as long as they have the same. Then if the base over here is 10, the base over here is E, you still have the same value. That's the whole point they want to demonstrate. Now, going into something that I think you guys will see, using a logarithm to evaluate or to measure the intensity of your speaker phone or your, remember the microphone, or let's say our theater. You see people wear, the actresses and actors, they put on a microphone to increase their intensity. And it is measured by this formula right here. The L, and that is the loudness of the sound. And now it is measured by this formula, 10 log of I over I0. Remember the microphone. Imagine the microphone. You speak into the microphone and your voice is louder and louder. It is controlled and is measured and using this property, the property of logarithm. Okay, look. For a sound with the intensity I, okay, in watts per square meter, and the loudness is the whole thing right here. That's the loudness of the intensity. All right. So an artist in a recording studio turns up the volume of a track so that the sound's intensity doubles. It's double. So how do you double that? So what is, now you are going to measure what must be the loudness increases when you double this thing. Okay, look, rewrite the formula. You want to double that. Look, double that, which is L right now, double that, 2I, okay, that's one to double, minus you want to double. So what is the intensity? What is they call it the decibels, okay? Double that minus I itself, okay? So just the formula. That's how you express double the intensity. All right, now let's write this guy. Your I right now turned into 2I. So I'm going to rewrite this guy for you, okay? So this, now, using two color, 10 log, whatever I right now is going to be 2I. There we go, 2I, okay? And I0, they gave you, I0 is 10 to the negative 12 watts per meter square. Okay, over what? Over I0. Okay, minus with I, minus with 10, okay, log base 10 I over I0. Okay, so what does that equal right here? Before you do this math, can I go ahead and just really separate this? Look at this right here, 10, okay, you see that, 10, look, a quotient rule. So I have right now is log of what? Log of 2I, okay, You can do this too. You can do this right here. Log of 2i, okay? And look, I am going to just do one step at a time for you. Here you go. I mean, you can see this. You can see this. Or how about I use, because for the sake of space, it's limited. Look at this. Look at this. This is a good application. Look, I'm going to rewrite this guy right here for you to see this. Can I rewrite this as 2 times with I over I0? Yep. Can I do that? Say. Now, I will use the product rule. I use the product rule. Log of A times B is log of A plus log of B. There we go, ladies and gentlemen. That is a very good handy property. Look, I rewrite 2i over I0 as 2 times I over I0 and applying the log. Log of the product is the sum of the two right here, okay? Now, minus with 10 log of I over I0. That's the guy right here. And see it? All right, close right there. Now look, I'm going to distributive 10 in. 10 distributive in, and then 10 turn in right here. So this parenthesis is gone. This one I got 10, okay? This 10 right here. This one I get what? 10. This one, look right here, plus with 10. But these cancel out. And now all you have is log 10 times log of 2. Okay, and the base is 10. So you got about 3.01. That's the unit over here is called decibel. Decibels. There we go. It's just a technique how to use logarithms to figure out the increasing sound in your microphone. All right, guys, have fun. We're done with this example, and we conclude 7.5. Okay. All right. I see you next video, guys.